Hello, my name is Kelly Benedict and I will be your physics teacher this year. If you are watching this video, you were probably absent either Wednesday or Thursday before Labor Day. So we did a 5-point assignment called the Reaction Time Lab, and to get those 5 points, at some point you will need to complete the lab. I'm going to go through in this video how to do it and the instructions to get you and help you be successful for it. Okay, there's 2 ways you can complete it. You can just go into Schoology and print it off and do it on a piece of paper and hand it to me in class when you come back. Or you can do it in Notability and submit it to Schoology that way as well. Either way is fine. It'll only take you a few minutes, just a quick way for you to refresh your memory on some math skills, and then to kind of do a little bit of lab work and see what physics might be like for you. Alright, so first thing to remember, it's been a while since you've used a meter stick probably. In 1 meter, so a meter stick is this long right here. 1 meter is the same as 100 centimeters. So there are 100 centimeters in a meter. Alright, from here, we are going to calculate your reaction time. So we're going to see how long it takes for you to react to something, and we are going to do that by having you catch something. You are going to need one other person, and you need a ruler. You can use a meter stick if you have it, but most people just have a ruler. And on one side of your ruler will have centimeters, on the other side will have inches. Just make sure you're on the side that has the centimeters. Alright, here's how somebody at home with you or a friend, they need to hold the ruler for you, and then you're going to put your fingers all the way at the bottom at the 0 centimeter mark. They are not going to tell you when they're going to drop it, but they're going to drop it. When they do, you are going to catch it. You are then going to look to see how many centimeters it fell before you were able to react and catch it. Alright, for me the first time it went 21 centimeters. It's not really good when I'm dropping it for myself, but sometimes people catch it anywhere between 5 or 6 centimeters all the way down to 30, 40, 50 centimeters, just depending on how quick they're able to react to it. You are going to do it 3 different times, and then you're going to come up with an average. So 3 different times you're going to catch it, you're going to get your distance written down in centimeters, and then you will add the 3 of them together, divide by 3 to get the average. Your average just for distance was that many centimeters. Okay, then before you can start the math piece of it, you have to convert. We got to get the centimeters into meters, because in order to use our equations, the distance always has to be in meters. So I'm just going to give you a sample problem for that. Let's say your average distance, let's just say it was 25 centimeters. If I want to change that into meters, I need to divide by 100. Okay, and I will teach you all about conversions here coming up in the next week, or actually I'll refresh your memory because you've learned all about them in chemistry. But whatever you have to start with, automatically that has to go on the bottom of your conversion factor so that they can cancel out. So I am starting in centimeters. I need to get rid of centimeters so they go to the bottom, and I want to change it into meters. For every 1 meter, there's 100 centimeters. That was right here up at the top. To change it into meters, I have to divide by what's on the bottom. So I have to take 25, divide it by 100, and that would be 0.25 meters. Alright, if your average distance was 15.5, divide it by 100, 0.155. If it was 10 centimeters, divide by 100, it would be 0.1 meters, okay? So whatever you do, you have to first get your average distance in centimeters, and then you have to divide it by 100 to convert it to meters. Okay, from there, then we are going to calculate our reaction time, okay? Here is the equation that we're going to use in order to do it. We're going to learn all about all these variables throughout the first month of school or so, but we're just going to try it today so that you can kind of get an idea of what you're going to be learning. Okay, delta y up and down vertical. This is your vertical distance, how far it fell. Alright, so whatever your distance in meters was right here, that number is going to go in for delta y. So if mine up above, 0.25 meters, this would be 0.25 meters. So however the average distance it fell has to be in meters is going to go right there. VI, V is velocity, and I is initial. The initial velocity of the meter stick, as before it drops, it's not moving. It has an initial velocity of 0. A, acceleration. It accelerates due to gravity. Gravity has a set number in meters per second squared, and it is negative 9.8 meters per second squared. I will teach you all about that coming up. Today we just need to use the actual number in order to calculate our reaction time. It is negative because it's moving in the downward direction, not because it's below 0 on the number scale. It's the direction that it's moving. Our unknown, we are going to be looking for delta t. All right, here's the equation we're going to use. Delta y, the distance that it fell in meters. We set that equal to initial velocity times the time. The initial velocity is 0. Anything times 0 is 0. So that whole chunk of the equation for this is going to cancel out, which is going to make our math a lot easier. Then it's 1/2 times a, negative 9.8, times t squared. All right, you're going to plug in all the numbers that you have. The only thing that I don't have written up here so far is the delta y, because yours is going to be different than mine perhaps. You're going to plug it in, you're going to move everything away from t, and then you're going to square root it in order to solve for your reaction time. So how much time did it take in order for you to react? All right, so the equation is going to end up, because we're cutting out this chunk right here, it's going to be 1/2 a times t squared. You're going to be able to put in a number for here. I'm just going to put a sample number in, 0.25. That's pretty far. Most people can catch up before that. 1/2 negative 9.8 times t squared. In order to make your math work, this 0.25 meters, technically, it gets a negative sign because it's moving in the downward direction. Not a big deal if you forget it. The only problem is we've got a negative sign over here, and we're going to end up having to square root. So we need to divide in order to get those two negative signs to cancel out. If it doesn't work for you, that's totally fine. Just make sure when you go to take the square root, just get rid of the negative sign then. In order to do the math on this, I highly suggest you just condense everything. Okay, so on the left side, I switch to one more color, I have a negative 0.25. If I take 1/2 times negative 9.8, I get negative 4.9, and that is still multiplied by t squared. I need to get t alone. I'm going to have to divide both sides by the negative 4.9 to move it to the other, to get rid of it, and then I'm going to have to square root. A quick reminder, I just said it, if you have a negative sign right here, before you square root, just get rid of it and take the square root of it as a positive number. All right, you will get a reaction time. It should be a decimal. It's usually like 0.1, 0.2, 0.3. Okay, so if you get a bigger number than that, you might have done your math wrong, so just make sure you ask questions when you get back. For problem number 2, you're going to be working the other way. You're going to use the same equation, delta y equals 1/2 a times t squared. But this time, I'm giving you a time. We still know the acceleration is due to gravity. You are going to solve for the distance that it fell, delta y, so you just multiply those all together, and then it always comes out in meters, so your last step, you're going to use your conversion factor from centimeters to meters to change it back into meters. All right, so I'm sorry I missed you those first couple days of school. I will plan to catch up with you when you are back in class on Wednesday the 8th, I think it is. And then if you have any questions on this, you can ask then. Otherwise, bring it with you, or you can submit it in Schoology. So thank you.